Okay, great. Let's get started then. We are in CSSS 508. It is the week 1. I am Breon, and it's March 31st, 2022. Trying to think if there's anything else to, that's it. That's all of me. Let's open up with some course goals. So first things first, we want to develop intermediate data management and visualization skills in R. I say intermediate, even though this is like the intro class, is because my hope is that by the time you're out of here, you have very strong skills in manipulating data, cleaning data sets, and providing visualizations, that kind of thing. The next goal is to learn basic programming. Basic here meaning that like sort of the foundational aspects of coding will be something that you're very familiar with by the time we get out of here. I'd also like to introduce reproducible research practices. I think one of the strengths of R is how clear everything is and how it's very easy for me to just take somebody else's code and replicate their entire paper from it. I'd also like to prepare you for statistics and CSSS courses. Now, this course actually assumes that you don't have any statistical background whatsoever. So most of what we're going to be dealing with is all of the peripheral things that you would be doing with R that are not necessarily the exact statistics that you might learn in a different CSSS course. And the reason that is because if you're like me, then you maybe went to take, let's say, MLE, and a lot of your experience was learning R alongside of like learning how to optimize a likelihood function. And this is like a kind of large hurdle. But if you already have some familiarity with R, then you can take a class like that and focus on the mechanics of, you know, convex holes and whatever else Chris wants to talk about. So who is this guy? I am Breon Haskett. It rhymes with neon. It's not French, just Breon. Welcome in. I am a 5th-year sociology PhD student, and something about me is I actually took this class as a first year. So I very much recall how it felt to see how hard some of the homeworks are. My research interests, I mostly study labor, pay-setting institutions, social stratification. Some of the examples will be in that area, but I try to take examples from the class from sort of the breadth of social science. My research methods are typically econometrics. I also am very fond of computational data collection. While we don't cover a ton of computational data collection in this class, I'm happy to field those questions throughout. I also have a strong inclination toward reproducible research practices. I think it makes us all just better scientists. A little bit about me for things that are not my research. I do write code every day. I'm opening up R or VS Studio or something every day. So I'm often at the computer. If you have a question on Slack, let me know. That being said, I'm a nerd, but only between the hours of 9 and 6. After 6 o'clock, I'm a geek. I'm going to be playing video games or watching movies or something. So I'm not going to be at the computer, so to speak. So if you send me an email after 6, expect that I will answer it the next morning. And the last thing about me is I'm pretty sure that social science programming is magical. Often, if you talk to a sort of like computer science nerd, you'll find that their version of what good coding is not what our version of good coding is. And the reason that I draw this distinction is because often in social science, we want things to be incredibly legible. We want the code to be very reproducible, and it doesn't generally matter how fast it runs. But a lot of other sort of coding practices and programming practices are really interested in making sure that things run as fast as possible on as small a machine as we can make it. And those kinds of things are not our bag. Rather, we are really interested in the team building and the community of creating a new kind of knowledge yet. Let's talk logistics. People who are in this room, you found Savory 117, congrats. Lecture like this will be here on Thursdays from 3:30 to 5:20. There's the recommended lab, which will occur also in this room on Tuesdays, 3:30 to 5:20. I'll talk a little bit more about lab as we go through today. And my office hours are going to be held via Zoom. I will probably just be at my own house for between 9 and 11 on Wednesday mornings. All of the course materials will be on the course website. I hope you got a chance to see it, mostly because I made it look really nice. I'm very proud of this, having all the UW colors and things. You'll note that everything in this class is written in R. So it was kind of like pulling teeth trying to get this cherry blossom picture to hang out on the sidebar, but I got it to work. The slides too are written in R. But that's probably not what you're here for. You're here to know about grading. This class is credit, no credit. You only need 60% to get credit, so you can fail and get credit. Homework, there's homework most weeks of the quarter, I think 7 or 8 weeks out of the quarter. And they're a combination of reading and programming. And there is peer grading for this class. And both those things are handed in on Canvas. We basically only use Canvas to turn things in and to assign peer reviews. There will be basically no other information there. Well, now that we've talked about adding the Zoom link for this class, I will also have the Zoom link there so you can click on it like other classes. Okay, do we have any other questions about logistics? I have a question about logistics. Can the people in the back hear me? I don't know if I'm talking loud enough. Okay, great. I want to address peer grading a little bit. I think that it's a really useful tool when you're learning a new programming language because you will write reports better knowing that others will see them. And not just others, not just me, but other people who will shame you. I mean, they won't really, but it's a really powerful tool to get you to learn how to do this stuff. But also you get to learn alternative approaches to the same problems. One of the really fascinating things that I get to enjoy instructing this course is I get to see all the distribution of how people answer all of the homeworks, and they can get very creative. The format of peer grading will be as follows. You'll be randomly assigned peers. It'll be due the following Thursday after that particular homework is due. So like our first homework is due next Wednesday, and the peer review for that is due the following Wednesday. The expectation is that you will leave constructive comments. That is more than just good job. On assignments 1 through 3, I expect you to write a few sentences at least. This might be difficult, maybe particularly the first week, if you're coming into R brand new, but I'd say it's worth just putting the effort and trying. Even if you feel like it's a lot of ungainly words, I think it's worth trying to figure out how to critique and what you thought was interesting about a homework. After that, weeks 4 and up, all of the lab times will actually just walk through the homework verbatim. So you won't necessarily need to provide very thorough feedback. And I'm very more happy with a good job, looks just like the lab kind of comment. Also, peer grading is rated by me, 0 and 1. So if you do just give a good job, I will give you a 0. Let's see, what else? Also, if you would like more feedback on something that you've done for your homework, just email me and I'm happy to read through it thoroughly and provide like maybe more thorough feedback. The materials, so all the course materials are on the website. These include the slides and the code that are used to generate all of the slides, the R script for the slides so that you can follow along in class. Let me give you an example. So if you go to like week 1 here, there's a thing that says the companion R script for the lecture 1 slides. If you click on it, it will just be a printout of all of the cases there was any code run in the slides that week. And so it's really easy to just come in here and just like copy paste it into an R script. And then it's easy to just kind of like click through, run stuff as we go along. Yeah. Let's see. What else is, I'm actually skeptical now that the I don't know where the Zoom controls went. Am I even recording? No, I am? Okay. We're just going to figure it out. And if the times that I'm like tabbing over to other things doesn't translate to the recording, I will just re-record this lecture sometime this week. Let's see. So there's the R script for the slides to follow along in class. Some weeks this will be kind of difficult because of the size of data sets and where the data sets are housed for some of the examples. But those will be made very clear and it will be okay. A lot of folks will tend to not follow the R script as closely once we're in like week 7 or 8 and the examples get kind of complicated. There are also PDFs of these same slides available on the course website if you'd like that instead. The benefit of those is that they're searchable and that these HTML ones that we're using right now are not. Let's see. There's also all the templates for the homeworks and the instructions for those. The video recordings of all the lectures and the labs. Although the first 3 labs are not templated homeworks, so I don't walk through them verbatim. I just kind of have a Q&A session and help troubleshoot everyone's code. There's also a lot of useful links to other resources, things that can help keep you on top of like what the current meta is in the R world. If you find something on the website does not work, please Slack or email me. There's kind of a ton of links. I try to check them pretty frequently, but it is a lot of stuff. Do we have any questions there? Sure.
Will you be recording the labs?
I will be recording the labs, but only for weeks like 4 and up, because the first 3 I will be like walking to people's machines and things. Cool. So about the lab, it is optional, but it is also recommended. For labs 1 through 3, I'll provide general technical support and answer any R-related questions you have, whether they're for the homework or not. So I tend to see that people come to the first week and are just like, hey, I can't get my markdown to print out as a PDF, like what's up? And we can troubleshoot that kind of question as well. Weeks 4 and up, we'll walk through all the homeworks together. This provides students guidance through the more complex homeworks. This also gives you the option of like 1, working independently on homeworks for maximum Ralph Waldo Emerson learning. There's also 2, reserving homeworks for lab if they are too challenging or time consuming, or 3, a bit of both. So some of the weeks the homework is kind of challenging. And I would say that just come to lab and then you don't have to worry about it that much. So I've set up the mailing list. It should be on the course webpage what our like email is that will like email blast our whole section. I would recommend to not use the email list to ask questions like this. I tried this linear regression of y by x and it didn't work. I don't like those emails all that much. Instead, say something like this. I have this data, y and x, and I ran this model and it's telling me this error. I don't know what this error means. That's a very useful email to me. And I can like look at this immediately be like, okay, well, this is too long vector. And that's why your code didn't run, right? Also, if you're not enrolled and you're like auditing the class or something, just let me know and I'll add you to the email list. It's pretty easy. There's also a Slack channel for additional communication. You will receive a link to join via that email list. So if you're not on the email list, like you're not going to get the Slack thing, but I'm pretty sure the Slack thing is on the course webpage. You can use it like the mailing list to ask questions, but it's particularly good for short questions. Things like, I tried to run the mean function and it was giving me an NA is like a really easy question to answer on Slack. The mailing list is really good for really long questions. I tried to run this k-folds cross-validation and it's not working because all of these nuances of my data is a very mailing list kind of question. I also encourage you to answer each other's questions. A lot of the questions are things that you will also run into and found a workaround for. So the Slack channel is good for that sort of like intercoder hangout. I'd also like to point your attention to Caesar. We're currently next door to Caesar. It rhymes with freezer. It's that building. It's that room over there, and also the two rooms next to us. They're also available online. They offer like data management and quantitative and qualitative coding consultation, which also means that they'll like help you with your homework. They offer really excellent consulting services for R. I'm pretty sure all of the people who work there have some familiarity with R. And I know for a fact that several of them have also taken this course and you could just like copy their homework. A quick note on slide formatting. I tend to use bold to indicate important vocabulary so that you'll remember them and like get used to the jargon of coding. Italics tends to indicate emphasis, but also used to point out when things you must click with a mouse. So like file print, for instance. And also these code blocks. They represent R code you type into the editor or console or keystrokes used to perform actions. For example, Control P to open the print dialog. I don't know how legible that is to you all because of the change in the projector in this room. Is this like gray to you? It's very light gray. I'll change that. There are also code chunks that are going to span the whole page. These are R codes that are embedded inside of the slides and are actively running when the slide gets made. So like this 7 times 49, this is what the output would also look like in R. So like this. That's this thing that happened down here is what is inside of this slide. You'll also find that lines that are preceded by 2 pound signs, 2 hashtags, represent the output or result of running code in the code chunk. We'll talk about this a little bit more as we move on. Okay. So the lecture plan is as follows. We have these 10 weeks and 10 lectures. The first of which is RStudio and R Markdown. RStudio is like the IDE that we're going to be using, and it's like on all of the computers that are in front of you. And R Markdown is a functionality within RStudio that allows you to create documents. In week 2, we'll talk about visualizing data. This class is very much in the tidyverse, the Hadley-Wickham format for coding in R. So we will be using ggplot2 to visualize data. In week 3, we'll talk about manipulating and summarizing data, which is kind of like the bulk of what we're interested in as social scientists. And this week's like pretty fun. Unfortunately, week 4 is like not fun at all, but it will have already been too late. In week 4, we'll get into like the nuts and bolts of how we made everything in the weeks 1 through 3 run, and things that in week 2, I'll be like, you don't need to worry about that right now. We will worry about in week 4. In week 5, we'll talk about importing, exporting, and cleaning data, any sort of data custodian work. This week is like so time consuming when it's not this week. Anything that's like cleaning data is just like such a heavy lift all the time. So I'd say pay attention, maybe especially well that week, like get an afternoon coffee. In week 6, we'll talk about using loops, and loops are really great when you need to like do something in succession a bunch of times, but they're also terribly slow. And in week 7, we'll talk about why loops are actually terrible and we don't want to use them at all when we're writing our own functions that run way, way, way faster than loops. In week 8, we'll talk about working with text data and things like regular expressions. And I have a bunch of addresses, and sometimes there's a period and sometimes there's an underscore. I don't know how to fix that kinds of questions. In week 9, we'll discuss some methods for working with geographical data. And this is like really fun for me. I don't get to, in my own research, make a lot of maps, but I do get to watch y'all get really excited for your own research as you get to make a lot of maps. And then in week 10, we'll talk about reproducibility and model results. Like I said, this class assumes that you don't have any statistical experience. So the model results thing is just to like expose you to best practices once you get that practice yourself. Okay, let's get into like the class. So why R? R is a programming language that's built for statistical computing. If one already knows Stata or similar software, like why would you want to use R? First, R is free. It's free 99. You can download it anywhere. It's super cheap. So you don't need a terminal server. You don't need to update the license. It's okay. You can just have R. The next thing is that R is a very large community. As part of it being free, lots of people use it. For instance, like for a long time, Kirk Goldsberry was using it, and like he makes basketball statistics for a living. It's a very, very large community. The nuances of the statistical packages you might be using go very nuanced. You can compare this with like, I don't know, Julia, which does not have that sort of large community of statistical goodness quite yet. The next great thing is that R can handle virtually any data format. I have not seen a data format that R cannot handle. There aren't any like weird proprietary things you have to convert to. It tends to just kind of work. The most flagrant description of this I've seen is somebody converted like old punch card statistics data things into their R instance. And I think that's just like, that's wild. Next, R makes replication easy. I know that in some languages, you just kind of click around and do things, and then you have a model result. But this makes it very difficult for some other observer to come and reproduce what you've done. Whereas in R, it's really easy to keep track of every single thing that you did throughout all of a project. Next, R is a language and not necessarily just a stats package. So it can kind of do everything, like make these slides, like make our course website, like make little video games, but it's mostly built for statistical computing. But since it's flexible enough that you can do those other things, it's just useful to get into because you get to have really creative approaches to problems. And lastly, R skills transfer to other languages like Python and Julia, if you do find yourself getting into yet nerdier places. So RStudio. RStudio is the front end or the integrated development environment for R that will make your life easier. RStudio can organize your code output in plots, autocomplete code and highlight syntax, can help you view data and objects. It enables easy integration of R code into documents with R Markdown, which we'll get to in a little bit. It can also manage Git repos. You can run interactive tutorials. And it can also handle other languages like C++ and Python and SQL and HTML and shell scripting. One thing I would say with the caveat there is that I find that the Git repo functionality in R is kind of not my favorite. If you are a Git user and you're like interested in that, I'd recommend just using like the desktop app or something, or just using the command line instead. Okay, trying to sell you on R Markdown. The ability to create R Markdown files is a powerful advantage of R. This is a document, you can document analyses by combining text and code and output all in one really neat package and make it look really nice without having to work super duper hard on it. But some of the advantages of that is that you don't have to copy paste into Word, not having to like copy paste table summaries or your graph that you made or something, way easier. It's easy for collaborators to understand. I find myself like sending them like a very small R Markdown with things like, I ran this set of covariates and I was surprised that we had sort of like a, I don't know, a Simpsons paradox thing going on with one of our variables. And it's really easy to make that kind of really quick document in R Markdown. You can show as little or as much code as you want. For instance, I wrote my master's thesis in R, and like none of the code is in the text of the document, of course. But the PDF is just the R code that I can run. You can produce many different document types as output. Things like PDF documents, HTML web pages, Word and PowerPoint documents, or presentations like the slides that we're on today. It also works with LaTeX and HTML for math and formatting control, which I'll show you a little bit more of later. Okay, so getting started. You can open up RStudio now and choose File, New File, RScript. I'll show you that now. File, New File, RScript. And what we're looking at here is in the top left, we have the code editor pane. This will be where your data gets viewed, but also where scripts get written and saved. And so this is a place where, like, if you want to write a code, save it, and then send it to somebody, this is that pane in the top left here. In the bottom left, we have the console for running code. You'll notice the caret prompt. This is a place where if you want to write, if you want to write code that's not going to stick around, you're not going to be saving it, this is the place to do that. For instance, if I wanted to just do a quick math, like the other day, it was Girl Scout cookies, so I had $11, and then I bought a box of Girl Scout cookies, and then I had $6. But like, I don't want to tell anybody that I only have $6 now, so I'll put it in the console. Whereas if I'm like trying to keep track of my books, I would say like this. And now this is going to stay here and I can save this and it will know that I did that calculation. Yeah. In the top right, we have a list of objects in the environment, as well as the code history tab. So all of your like data and things will be saved here when it's not empty. You can also see the code history of all the things that I've run so far. Oh goodness, in the last long time. This is actually examples from the homework 7 from the last time I was teaching this course. Is it saved in the code history up there? And in the bottom right, we have the tabs for browsing files, viewing plots, and managing packages, as well as help files. So down here, this is like my usual file explorer, as well as like all of the packages that are available for this computer to use at this time. Help page about the as is function. And this viewer would be populated with something if we were running a markdown, but we're not. You can change the layout in preferences, pane layout. I personally do not use this pane layout. I will for the purposes of this class. And if you notice that it looks incorrect, let me know, because I'm just so used to not doing it in this order. I'll tell you now what my preference is. I tend to put the console up here and the environment down here. So I just flip these two quadrants. And the reason is because I basically never look inside my environment in my own work, but I do use the console. And then so it will just look like basically this, but with the console up here. And then all of the plots get put out right here. And that's how I tend to use it. But, you know, that's not the default. Okay, let's talk a little bit about editing and running code. There are several ways to run R code in RStudio. The first is to highlight lines in the editor window and click run, or hit Control Enter. So we can highlight this and we can hit run, and we'll do this math down here. Or we can hit Control Enter, or Command Enter, which is the little loopy thing if you are on a Mac. We can also just put the caret on the line you want to run and hit Control Enter. And it will also run again. And this actually works in succession. So you could also say like, I don't know, 12 times 13. So I could hit Control Enter, and it'll just keep jumping down lines. You can also type individual lines in the console and press Enter. I showed you that before when I was talking about not wanting to tell anybody about the Girl Scout cookies. And then in our Markdown documents, you can click within a code chunk and click the green arrow to run the chunk. And there's also a button beside that that says run all prior chunks. We'll get there in, I don't know, half an hour. The console will show the lines that you ran followed by any printed output. So you notice that like even in the script, when I run this, it shows me the output of that down here in the console. So if you mess up something like you leave off a parenthesis somewhere, R might show a plus sign prompting you to finish the command. So I will just go back to this example here. Put it on here, and you'll see that it just throws me this little plus sign, and I'll be like, what? That was correct. I don't understand why you're not doing it right. You hit escape, and it will give you back the caret, and then you can add a parenthesis, and it'll know what to do. R is a really decent calculator. I say decent as like an inside joke to myself and any mathletes that we have, that its floating point precision is pretty good, but not excellent. In the console, you can type 1, 2, 3 plus 4, 5, 6 plus 7, 8, 9 and hit enter. And you should get something like this. Note that the 1 in this output indicates the numeric index of the first element of that line. This might not be terribly useful right now, but I want to highlight this just so that we understand why it's telling us this one right here. As you will start to get more output in your console, there are things that are not just this one. Okay, now in your blank R document in the editor, try typing the line sqrt open parentheses 400 close parentheses and run it. I will also so that's what I got. Are y'all with me there? So let's talk a little bit about what functions are and help. So sqrt is an example of a function in R. If we didn't have a good guess about what the square root function will do, we can type question mark and then the function name in the console, and it will give us the help view. So we can, in the console, say question mark sqrt. And then down here in this viewer, it'll give us this sometimes useful, sometimes not help view. So here it says miscellaneous mathematical functions. Square root computes the principal square root of x. And it'll say that it takes the arguments x, which is a numeric or complex vector or array. And for a lot of new users, they look at this and they're like, that's not information. You're kind of just throwing words at me. And one thing I'd also point to is that help tends to have a citation. So if you are interested in something very particular about a package that you're using, they tend to have a references section. This one is making reference to the new S language, which R is just like a better version of S. And then also they tend to have an examples thing that you can just copy paste to see like a use case of what you're doing. But this use case is just like also illegible to me if I don't really have a ton of math experience. But thanks. Anyway, that tends to happen with a lot of the really fundamental and foundational functions built into R, where I find them personally to have not great help pages and not great examples of what they do. But that's because they kind of expect that you know what square root is. So earlier I said like X is its arguments that it can take, and it's a vector or numerical array. Arguments are the inputs that go into a function. So like in the square root function, we just like typed in 400. The argument that we gave to that function was 400. Cool. Let's talk about creating objects. So R stores everything as an object. That's data, functions, models, output, all of it gets stored as an object in your environment. You can create an object by using the assignment operator, which just looks like an arrow pointing to the left. It'll be a less than and then a hyphen when you want to type it. So you could say, for instance, new dot object, assignment operator, the number 144. And if we run that, now in our environment, it'll say there's this thing that's called new dot object, and it's like populated with the number 144. One question I like to preempt is that you can assign things pointing to the right if you'd like. It's the best practice to point everything to the left. At least I find that to be the best practice in English speaking R users. I don't know if in other languages it makes more sense to point things to the right. I've seen that in some code, but I will say that it tends to be the case to point things to the left and assign things this direction. So the assignment operator and other operators like it are functions that look like symbols, and they typically sit between their arguments. So their arguments, instead of like going inside of a set of parentheses, go in between or go on either side of the operator. We're very familiar with things like this, like the plus sign is an operator, a mathematical operator. You can call objects or display an object simply by using its name. I will probably say call a lot when I mean to display something. So we can say new.object now and just run this, and it will print out in our console the number that is underlying it, because they're fundamentally the same thing now in our R environment. Object names can contain underscores and dot in them, but they cannot begin with numbers. So things like 21 Savage is like no way, but Deltron 3030 we can get with. So try to be consistent in naming objects. RStudio autocompletes. RStudio autocompletes, so that means long names tend to be better than vague ones. So I'm not a big fan of when I read a cool paper and I want to reproduce their work, and I just like download their work from the Dataverse or something, and their models are just like mod 1 and mod 2. Instead, when they're like intercept model, yada yada, that's like more useful. So let's just say we like said intercept model and gave it the number 13. Now when I go to type intercept model, like it'll autocomplete for me and I can just hit enter, and that'll save you so much time and make sure that you don't misname things. Using objects. An object's name represents the information stored in that object. So you can treat the object's name as if it were the values inside. Okay, I'm going to say that again. You can treat the object's name as if it were the values that were stored inside. So you can do things like new.object plus 10, and it'll give you 154 back. Or square root new.object, and it'll give you back 12. This treatment of objects in R becomes very useful when we're making R Markdown, which I'll show you in a little bit. And the last thing, I think before our break, I'll talk about creating vectors. So a vector is a series of elements such as numbers. You can create a vector and store it as an object in the same way. To do this, you use the function lowercase c, open parentheses, close parentheses, which stands for combine or concatenate. I tend to say personally concatenate because that's how I learned it. But I hear through the grapevine that other people call it combine, so I'm going to try to say both. So you can say things like assign to new.object with the assignment operator this list of squares. So I'm going to run this. And we'll see now in our environment, it says new.object is something with a length of 5. That's numeric. That has these elements 4, 9, 16, 25, 36. Note that they're separated by commas. Commas are the typical way to separate things in R.
The same type of element, like can you
You can, but one thing to note, let's say we replace 36 with A. It will change the type of the whole vector. So like now it's a character type, and all of the elements become characters. So it's not the number 4, it's the text 4. We'll get into talking a little bit more about that later, but because vectors can only have one type of thing inside of them. If you name an object the same name as an existing object, it will override it. Remember when new.object was 144? That's gone now. We're never going to have that again. And it's really hard to check that if you're writing in the console, for instance. So be very careful when you're assigning things to not name things the same if you don't mean to overwrite them. You can provide a vector as an argument for many functions. So now we can just do like square root of our whole new.object, and it will piecewise square all or root all of the things that are inside of the vector. More complex objects. The same principles can be used to create more complex objects like matrices and arrays and lists and data frames. And data frames are just lists which look like matrices but can hold multiple data types at once. I'm saying this right now, and you will forget I've said it by week 6. Most data sets you will work with will be read into R and stored as a data frame. So this course will mainly focus on manipulating and visualizing those objects. So like the typical things social scientists might use, the ACS, the census, comes to us as a data frame. Before we get into those, let's revisit our Markdown. Right here, I'd say let's take a break for 5 minutes. I've been talking a lot, like more than I have in months. So yeah, in 5 minutes, we'll come back. Okay, so we're going to be talking now about R Markdown. And I want to first off apologize for not teaching you Quarto instead. And the reason that I'm apologizing is because, one, I think it's funny, but two, I haven't really used it that much yet because it came out, so far as I know, like a month ago. So yeah, I'm not I'm not qualified to teach you that right now. But maybe once you're done with the class, look up Quarto. It's going to be like R Markdown, but you can like use it between different languages, which I think is really neat. So probably the next time I teach this class, I'll teach Quarto instead. But we're going to learn R Markdown. Also, Quarto is written by the people who make R Markdown. So it should have a lot of the same good things about it and maybe less of the whack things. So let's talk about R Markdown documents. So let's try to make one. We can go to RStudio and go to File, New File, R Markdown. And we want to select the HTML output format for this walkthrough right now while we're in class and for all of our homeworks. Although you can output to Word and PDF, we will be dealing with HTML because it's easiest for the Canvas interface for our purposes. Okay. So the next thing you're going to want to do is, once you've created that document, save it somewhere, call it something like my first rmd.rmd. And you can click knit HTML. It is this little ball of yarn and knitting needle. And depending on your machine and what version of R you have, you might get your own separate page here like this, or it might open in this little viewer panel down here. Either way is fine. It just depends on when you downloaded R for the first time and whether or not you've updated it since. But this is like the default HTML document that comes with R. You may also open the file in your computer's browser if you so desire. You can click Open in Browser button at the top of the preview window, like this. And it'll open up in your browser for you. That's the same technology that's like running our slides right now, is how it's opening up in the browser like that. So let's take a look about what's happening in our markdown. The first thing to note is that the header of a markdown, a .rmd, is YAML. And YAML, of course, stands for YAML ain't markup language. It's a code block, and it's its own like coding language, YAML. So it might look something like this. Here we have like the title, and the output is the HTML document. And you'll note that it's in between these like 3 hyphens on top and bottom of it in the lines. So things that happen in the YAML work under a different sort of syntax and behavior than things that happen in your R markdown document. So anything that's below this like 3 lines at the bottom here. You'll note, for instance, that like the title has 1 space between it, and so does the name and the date and the output. Those spaces matter a lot in YAML, but don't matter in anything below the YAML part. So I just want to say that now before you get to your homework and you're like, I'm ready to make my homework look really cool, and it's not working. Sometimes it's because of just the spaces. For instance, you can mess with the global formatting by changing the header. So I'm just going to copy paste this like this. And when I knit, you'll note that like all of the font has changed and things look slightly more DPI. I guess I should also show it breaking. So maybe it won't run because of this space. Whereas most things in R, aka things in your markdown below this YAML part, the spacing doesn't matter all that much. So let's talk a little bit about some syntax that you can use in the body of an R markdown document. So things with 2 asterisks on either side of them with no spaces, we'll put things in bold. Things with 1 will italicize things. Things that are a hashtag, then a space, then some words, we'll put that in header text. And the more hashtags, the smaller the text will get for headers. You can also use the caret to block quote things. If you look at the code for the slides, a lot of these things are just kind of written in between them in a very seamless and useful way. The codes for the slides are just on the webpage. There's some other R markdown syntax that you might want to use. For instance, if you want to make a list that's in order, you just put the number 1 before every element of that list. So you don't have to keep track of the numbers yourself. It'll count them all for you. And if you just tab over, you can have like nested numbered lists. Unordered lists, just use 1 asterisk and then a space in order to create bullets. To create URLs, you put the text of what you want your URL to say in between square brackets, and then next to that square brackets, parentheses with the link inside. So here I said URLs are trivial, and then put the link to the UW website here, and you click on this and it takes you to the UW website. You can also put in pictures. I found I had a really tough time trying to find a UW picture where the link wasn't super duper big. So I'm sorry that it runs on like this. But in order to embed a picture that's from a website somewhere, you can just put an exclamation point before this, and it'll put out. You can also include formulas. for like your stats classes and things within the body of your document. So you can put some math, like y equals 2/3 squared here, and you put it in between these dollar signs. And you just use regular LaTeX in order to write all of these things, or these big blocks of math. Like when you're reading a paper and they have their model situated in the middle of their paper, this is how they do that in R Markdown. You can also write a sentence with code font in it. I will be making this darker so that everyone can see it later, but it is in a separate font. You can also include blocks of code, which every once in a while you'll want to see within the text of a document. You can just use 3 backticks on either the top and bottom lines between what you want as a block of code. I'm going to say backticks kind of frequently in this class, and I want to point out where they are on the keyboard because there's virtually no other reason to use them but when you're coding. It's the button that's right below the escape key and right above the tab key on the left-hand side. And it's not an apostrophe. It's not an akina. Here I provided a lot of useful resources for tinkering in R Markdown. R Markdown documents can be modified in like many ways. So you might want to visit those links for more information. I tend to just use the definitive guide that's written by Yihui Shi, who writes like most of the cool R Markdown stuff. And also is very active on Stack Overflow. So like if you have a really weird question about R Markdown, they'll answer you. So a few caveats about formatting things in R Markdown. To keep R Markdown simple, it lacks some features you might occasionally want to use. So your options for fancier documents are to use templates. I showed a template here, like this is a template that made all of the font and things look nicer. And you didn't have to like set it up yourself. You can use HTML with CSS for custom formatting. So that's how like these slides say UW CSS and stuff on them and have little cherry blossoms and what have you. You can also use LaTeX. And this .rnw means Sweeve. It's a Sweeve file instead of R Markdown. I haven't had any experience with these, so if you ask me a question about this, I will have to direct you to people who know better than me. But you'd be surprised how wildly specific LaTeX can get. If you're writing a paper with some people and they know LaTeX, cherish them. Maybe bump them up like 1 in the author order. For day-to-day use, plain old R Markdown tends to do the job though. For handouts, memos, homeworks, default R Markdown PDFs look surprisingly good, and just like the default settings for a lot of things is fine. So let's talk about including R code in our R Markdown. So all of that other stuff was just so that you could type in the body of your R Markdown. Actually, let me back up and like show you what I mean. So like the other things we were talking about, I will just delete all of this. Was like, we could say, these are bold words. And now when I run this, like this sentence is here and it's bold and written. But this is like not R code. This is just the sentence within my document. Now we're shifting to talking about how do we put statistics and math and whatever else in our document. So inside R Markdown, lines of R code are called chunks. This is code that is sandwiched between 3 sets of backticks and then a curly brackets lowercase r, and it'll look like this, okay? And you might be saying to yourself, like, that seems like terrible to want to write. When you're in R Markdown, you can click or type Control-Alt-I, and it will just create a code chunk for you. I do believe that you can also put a code chunk by clicking here. Here, this little green C. We all see this? And I think this also produces a code chunk for you, which is faster than typing 3 backticks, curly brackets, lowercase r, curly brackets, enter, enter, 3 backticks. So if you take this code chunk and you run it in your R Markdown, it will produce this information here, telling us a summary of our cars data set. And it just tells us like the min, median, mean, max, and your quartiles for these 2 variables in this data set. Some chunk options that are available to you. So chunks have options that control what happens with the code within your R Markdown document. So you can say things like echo equals false to keep the R code from being shown in the document. So in this case, we have our summary, and without any other information there, we'll see that what happens is it says in this little like gray box, summary cars, and then the output. But if we say things like comma echo equals false, it no longer has that like gray block telling us what code was run. It just produces the output. So other chunk options that are available are eval, which says whether or not to run the code. A lot of eval equals false is in this slides all the time, just so I can show you what the code looks like without it running and making the slides run slower or what have you. There's also include equals false, which hides all the output, but still runs the code. This is really good when you want to like set up chunks where you load packages, or when you have a very particular kind of graph that needs to be made and you want to clean all the code for, or clean all the data first, that kind of thing. You can say results equals hide. Now hide is in between apostrophes, again, because just like coding's kind of wild like that sometimes. This hides any non-plot output from the document. So it will, results equals hide will not hide plots. I don't know. Cache equals true is really useful. It saves the results of running that chunk so that if it takes a while, you won't have to rerun it each time you reknit the document. We'll have a couple of examples of why you'd want to use that in this course for homeworks where we have like really big data sets. And if you wanted to just like, I messed up typing today's date, you don't have to reload the whole huge document and data again in order to change that. You can also set the size of figures within chunks. I've named like a bunch of the ones that are like feel I use most often in my own work, but there are tons more. So highly recommend checking out this link. Playing with chunk options, try adding or changing chunk options separated by commas for the 2 chunks that are in your My First RMD and reknitting to check what happens. You can also name your chunks by putting something after the lowercase r, but before the chunk options. Yeah, after you name your chunks, look what happens in the dropdown on the bottom left of the editor pane. Naming chunks allows you to browse through our Markdown documents by the chunks names. And this makes it really quick when you get really big documents. So here in the original thing, they have already like named them in the default document, like chunk 1 setup, R Markdown's a header, chunk 2 cars, chunk 3 pressure. And this makes it so I can just go down here and like click on it and it will take me to where that is. And so this is really great when you're working on a paper and you're like, I'm only trying to change one graph that's at the end of this document, or like I'm looking for one specific subheader so I can change some of the text, that kind of thing. Okay. You can put R code in line of like the regular text that you write. Sometimes we want to insert a value directly into the text. We do that using code in single backticks, starting off with a lowercase r. So it look like this. This is what you would type into your R Markdown document outside of a chunk in order to put an R code in something that's outside of a chunk. So you'd say 4 score and 7 years ago is the same as backticks lowercase r. 4 times 20 plus 7 backticks years. And its output will look like this. 4 score and 7 years ago is the same as 87 years. And this is tremendously useful because we can save a variable in a chunk that we want to reference in the text. So we can say assign to x the square root of 77, and we can say the value of x round to the nearest 2 decimals is r round our variable to 2 decimal places. That's what this is saying. And it will just output 8.77. Okay. I think this is amazing. Having our dump values directly into your document protects you from silly mistakes. You never have to wonder, like, how did I come up with this quantity? What is this number from? At what stage did I round this value? You can just look at the formula in your Markdown and change it accordingly, or check the trace of how you came to that quantity. Consistency. There's no find and replace mishaps. There's no single dwigged. You can reference a variable inline throughout your document without manually updating it if the calculation changes, something like reporting sample sizes because you got more data. You're more likely to make a typo in a hard-coded number than you are to write R code that somehow runs but gives you the wrong thing. By hard-coded, I mean when you just type the number right into the document. For example, in your YAML header, make the date come from r's sys.time function by changing date to, like, from this to backticks r sys.time. And even fancier option, the one that was used to like make the header of this slide deck, says format sys.date with the format being with I forget the name of why the time is formatted with a % and a capital B and all that. It's escaping me right now. So that's how it makes it look all nice on the front of the slides. Okay, do we have any other questions about like all of that sort of formatting stuff in our Markdown? The homework is asking you to like work through and practice with a lot of these tools. So I don't expect that you have like all of this together. And in fact, I want to reiterate for the class. I don't know if I said it in the beginning, actually, so I don't know if it's a reiteration. So the format of this class is to try to just like give you a buffet of all of these R things with limited expectation that you have mastered them all by the end. This is on purpose, and the reason that the like course website is like not a canvas is so that you can always go back and check things, and you can always like be like, I don't really remember how to change this data or manipulate it in a specific way, but I remember Breon saying something about that. It was kind of in a homework one time, and that is like that practice of like going back and checking that is just like always what you're doing in coding. There are a lot of things, I'll point them out as we go throughout the class, that I forget on a regular basis when it comes to coding, and I just have to look it up every time, and that's okay. So that being said, there will be a lot of times in this class where you'll feel like I'm saying a ton of things. How am I ever supposed to follow all these? But in part, it's by design. That being said, we're moving on to talking about data frames. Do we have any questions about our Markdown before we move on to talking about data frames? Question.
How do you save the like
Save iteratively?
Like I've got to name this like my first RMD and it's saved. Like do I have to save it again? Like and make changes, or do I save those changes?
Okay. Let's see. I'm trying to think about. Okay, so there's two things. First, I would say that maybe you would look into version control. So like that is to like save things to like GitHub and like send them and have them so that you can always check back. The second thing would be that when you knit a R markdown, it always saves again to produce the output. And the third thing would be that you can save your R history document and it will keep track of all of those little changes if you'd like. But typically the best practice is to not have an R history file because it allows you to have a clean workstation every time that you go back. So that's answer your question. Okay, cool. Cool. Any other questions?
So when you make the R markdown, it runs everything in the markdown and then it produces the HTML or PDF. But if you only want to like run parts of it, then you just have to run it.
Sure. Yes, so you could, if you'd like, go to your R markdown document and just like click here and it will run piecemeal. So you could like go and just like scroll through and click, and then it wouldn't produce the document and you could still see it here. That was the thing that we were talking about earlier when we were talking about how do we run stuff. We can just click on these green things to run the current chunk or run all the stuff in the document up until this chunk. That's what these two things mean here. Great question. Okay. So let's talk about the cars data set. In the sample R markdown document you are working on, we can load the built-in data cars, which loads as a data frame, a type of object that was mentioned earlier, you might recall. Then we can look at it in a couple different ways. So we can say like data cars. Since cars is built into R, you can just kind of say that. Something like this. And one thing that you'll note is that if you run data cars, it will start up here and it will say, you have an object named cars, I promise. It does not have any data in there. It's just a promise. It's kind of a goofy function of R. If you want to learn more about that, I have a link here that explains it more, I think. But suffice to say that promises are just data that is there. And when called upon, it'll show up for you. But up until that point, it's just the name. So let's say I click on this. It's been called upon. So now it's going to be like, okay, we have 50 observations of two variables here. You can use view cars, and this pops up a viewer pane, which allows you to like read the data as you would in like SPSS or Excel. Note that it's a capital V here. There are very, very few cases where there's a capital letter in a function. This is kind of a holdover for when R was S, and you'll get to know the very, very few exceptions where there's a capital letter in it. The capital V view cars will like show you the data in raw. Don't run view cars within your R markdown document. Did y'all hear that? Don't run view cars in your R markdown document. I already know, I'm saying it 3 times, it's being recorded, that it's gonna happen, but don't do it. Another thing you could do is say something like head cars, comma 5. And this will print just the first 5 rows of whatever you're looking at. You can also say tail, and that will print the last rows of whatever you're looking at for n number of rows. But that is a lot easier to do and is okay to do within an R markdown. So like if you say like, hey, cars 5, I won't get upset with you. That's fine. Just don't use view. Some other things we can do with our cars data frame is we can look at the structure of it. STR is short for structure. The output will look like this. It'll tell you that it's a data frame. It'll tell you it has 50 observations of 2 variables. And those 2 variables are speed and dist. Speed and dist are both numeric. And here's like the first 10 observations of each. So structure is really useful when you want to just tell me like in brief what is going on in this data frame. You can also use summary. This just displays summary information as it sounds like. And we saw this earlier, like it shows you like the minimum and the maximum and the median, whatever else. But note that summary is actually object oriented. So if you did like the summary of a linear regression, it would tell you all of your like covariates and p-values and stuff. And if you did a summary of like a vector, it would tell you yet different information. So summary is like wildly flexible for all of the objects that you can hand it in R. Let's talk a little bit about how to draw really ugly pictures. So the hist function generates a histogram of a vector. Note that you can access a vector. In other words, like a column from your data frame using the $, which we will call the extract operator. And some of the syntax of how that'll look is like this. You will say hist, the cars data frame, and then extract the speed variable. And this will give you a histogram that looks like this. Okay, so we'll say hist, and then our data, cars, and then $. And now the $'s like extract what? And our markdown or our studio is saying, do you want the speed variable or the dist variable? And we can say speed and run that, and it'll give us this really ugly histogram. The $' extract is how we can like take vectors out of different objects. We can take lots of things out of objects with the extract operator. We'll get to that later. We can draw slightly less ugly pictures by changing things within the hist function, providing it more arguments. So we can say the x lab equals, and then provide it in quotes what we want the x label to say. We can say main equals, and then provide it in quotes what we want the title to say. And you might be saying to yourself, how am I supposed to know that it's X lab and not X label or what have you? You can just go to the console and type $hist. And among the arguments that are in there, it'll say main, X lab, Y lab. The main title and axis labels, these arguments get smart defaults. Smart in terms of like it just tells you what you want to hear. It's a frequency on the y-axis, and the x-axis is what you provided it. And here are your other arguments that you could mess around with should you choose in the sort of default graphics package for R. Sorry, do we have any questions about this? I was trying to provide like a small example. So when you get to your homework, you're like, I know how to draw one graph at least.
Should we put everything in one chunk or like separate? Because I saw you.
Sure. I would say that I tend to separate chunks so that I can mess with them each. And because big chunks can get confusing and it loses that like, oh, well, I could have named this very specifically and moved it around. Okay, let's talk about some math. If you put an assignment such as X or assigning Y to X in parentheses, R will print the output of the assignment for you in your document. Otherwise, it won't show the value. Let me show you what I mean. If you say the dist mean assigned to that, the mean of the cars data set, and extract the dist column, and you put that whole thing in parentheses, when you run this, it will print out 42.98, okay? So let me show you. Down here, I ran this, and it printed out 42.98. Whereas, if this was not in parentheses, it doesn't tell me anything. But it does, in my environment, have dist mean equals 42.98. Okay, now this was useful to assign things to dist mean and speed mean so that we can draw still ugly but less so pictures by creating a scatter plot of our cars data using the plot function and saying that we want dist tilde speed. This tilde here basically means by. You notice it in formulas a lot when you're working in statistics. But here we have dist and speed, and then we've given the X and Y labels useful names. We've decided that the point size is going to be 16 so that they can show up a little bit better. And then we've added a horizontal and a vertical line at each, the mean of distance and the mean of speed, which were those variables that we assigned in this slide. And you might also be saying to yourself, how do I know these colors? On the course webpage, it shows you where all the colors are. But if you also want to know what the names of the colors are, there is a colors function. And if you run it, it'll tell you all 650 some picture or colors that are available in base R to you that have names, but are also like flexible for hex codes and other kinds of coloring schemes. Okay. Now let's switch gears to the Swiss data frame. I believe your homework is using the Swiss data frame. I don't remember. First use question mark Swiss to see what things mean. So let's try that out. Swiss. And in the help viewer here, it says it's Swiss fertility and socioeconomic indicators from 1888. And its format is it has 47 observations of 6 variables, each which is in percentages. So everything's between 0 and 100, except for fertility, which appears to be the log of some common standardized fertility measure. Unclear exactly what that means, but other things are pretty more straightforward. Things like percent Catholic as opposed to Protestant in this area. Percent of draftees receiving the highest mark on an Army examination, that kind of thing. One time I did try to go through and read like sources of like where this data came from. I wouldn't say it's terribly worth your time. Okay, then we can load the data using data Swiss. And we'll note in the environment, it is promised to be there. But as soon as we want to do something with it, we could like say structure Swiss. It will populate up here. It's no longer a promise. Sorry that structure Swiss gets all weird with the size of the font. Okay, so now you can add chunks to your R Markdown, inspecting Swiss, defining variables, doing some exploratory plots using hist or plot. You might experiment with colors and shapes. We're running a little low on time, so I'm gonna not spend a lot of time doing that. I'm sorry. But I wanna make sure that we have like a really good understanding of what our homework's gonna be. And y'all can mess with plots later. So there is a plot called pairs, or a function called pairs. You can provide to pairs your Swiss data set and then give it like a specific type of point. That's what this number 8 means. The color is violet, which I don't think this is violet, but to each their own. The pairs provides a pairwise scatter plot, and it's really good for looking at really small data sets really quickly. So like there's only 6 columns here, so it's really easy to just like say, I don't know, education and examination seems like it has a really steep relationship here, something like this. Useful, but do not recommend when you have like way more than 6 columns or like way more than 47 observations. Let's talk about installing packages. So one of the really great strengths of R is how many excellent packages there are to just do anything you want to do. One thing we might want to do is make a table that looks less codey in the output. So like our summary codes just look kind of blah. To do this, we'll want to install a package called Pander. Packages contain pre-made functions and or data that we would want to use. So in the console, you can type install.packages and then in quotes, Pander. So I'm going to explain a little bit about what's going on there. Install.packages goes to this, it goes and checks against a big repository of all these packages in R and looks for whatever you've asked for, okay? And in order to find exactly what you need, it should be in quotes. There are things that are not in what's called the CRAN, this big repository where all these packages are, that we will install in other ways. And I'll show you how to do that. But a lot of things that you typically want to use are going to be on the CRAN. So again, you want to say install.packages pander in your console here, okay? Do not put it in an R markdown. It'll crash your markdown. Your markdown will not run if you install a package in it, okay? And the rationale for that is your markdown can't talk with the CRAN. But one thing you will want to do is have a setup chunk. So typically at the top of your markdown, like right after the title, you're going to want to load packages there, okay? And let's just get rid of this guy for a second. And what you'll want to do is name it something like setup, and you'll say library pander, okay? Do not install packages here, but you can call in your package here, and that tells the markdown, hey, we're going to use this pander package somewhere in the body of this, and if we don't, just be ready to use it. Does that make sense? Okay. So install the packages for Pander, again, in the console, not anywhere else. Note that unlike the library command, the name of the package must be installed in quotes. Okay. Once you install a package, you do not need to reinstall it until you update R. Not RStudio, R. It's like the underlying engine that is being run on RStudio. Only when you update that do you need to update packages or like install packages again. Okay. Let's talk a little bit about what Pander does. So we load library Pander. Okay. You only need to do this once in your session. And your session is like since you've turned R on and until you like click X to get out of it. We can then say pander and wrap it around our Swiss summary and say that our style is R markdown. We hand it this argument. And then we say split.tables equals 120, which tells it just how far away in points you want the columns to be. And this looks far nicer than our just like regular output that we were getting in our markdown to start, to put things in a pander. I don't know if on your machine it will come out with this like nice little purple. I think that's from the CSS that I added to the Sharingan that runs the slides, but it will look nicer. One thing you might also want to note is that we put summary Swiss directly inside of the pander call. This is called nesting functions, and it is very common. I'll introduce a method next week to avoid confusion from nesting too many functions inside each other, because as you might imagine, they'll get pretty confusing and difficult to read the more things you might want to do, like having a summary, but I only want this particular column, but I want this column to have the mean, but I don't want to have the mean of this other part, that kind of stuff. We'll talk about that. So the data look a little nicer this way. Looking at the first 5 rows of this data, right? The head function lets us look at the top of our data frame. We'll also note that over here, each of our rows is named. I'm realizing now I probably should have explained, no, y'all can figure it out, how to get these row names to be their own column. But that's something that we'll talk about in specific, I think in week 3. So you don't necessarily have to do that for the first homework or anything, but you know, if you have some extra time on your hands, maybe look it up. Okay, do we have any questions about pander? Sure.
I think I'm installing it wrong, or it doesn't want to admit it exists. Can't get it at all.
Okay.
Very specific, sorry.
No, that's fine. How about right after class, I will come fix it. Cool. Okay. Oh, sorry. Hand in the back. Yes, it is. I actually have this here. I actually left that in so that other people could see that I also get that kind of message. It's not a problem. It's just trying to let you know that like this was built in a different time versus when your R is, and sometimes that matters. Most of the time it does not. The way that you would get rid of this is you could say, I think it's message equals false in your code chunk that has library pander being loaded in it. So it would look like, it actually might be warning. Yes, warning equals false. And if you ran it again like this, I'm pretty sure that it would not, this machine would not provide me that error. So we wouldn't be able to check right now live from this machine. But I'm pretty sure that would get rid of it.
Mine installed, but it also gave me a warning, which I was not sure whether to take that warning.
Okay, what's the warning?
R-tools is required to build R packages, but it's not currently installed.
I see. Let's see. If you need R-tools, you're going to have to download it in a different way. I think that might be the description of what's going on. I think enabling compilation of packages is what you would need to do. So your machine needs to do this part of this of the website. So if anybody else gets an error, I'm saying this for the recording as well as you all, that says like you need R tools in order to compile this, go to enabling package compilation in R on the top of important links on the course website. Of course. Great. So let's talk about what the homework is for this week. So you're going to write a markdown file showing some exploratory analyses of the Swiss fertility data. So that data Swiss that we were looking at. You're going to upload both a .rmd file and the .html file that is output after you knit to Canvas. You must upload both for credit. You're going to mix inline R calculations, tables, R output, and plots with text describing the relationships you see. So please say something about the relationships you see, something like, you know, use the correlation function and I see this is like a pretty decently strong correlation between these two things, that kind of description is fine. You want to include at least one plot and one table. You are encouraged to include more. You must use inline R calculations and references at least once. So things like, remember that backticks, lowercase r, and then an object within a sentence? Do that. And you may not hard code any numbers referenced in your text. Okay, so don't just type the numbers out, assign it to an object, and then call the object within the line. Your document should be pleasant for a peer to look at, with some organization using sections or lists, and all plots labeled clearly. Use chunk options echo and results to limit the code output you show in the .html. Discussion of specific values should be summarized in sentences in your text and not as printed code and output. And rounded so as not to be absurdly precise. So things like you can round x with the round function. The argument is x, comma, to 2 decimal places. And that'll give it. One question I want to make sure we know about is, let's see. I'm going to okay, so wherever you saved your markdown and then knit it, that's also where your HTML is. Okay, so I know I was going to get that question. It's in the same folder where you saved your markdown. And the last thing for the grading rubric, for when you are peer reviewing, it's like this. If they didn't turn anything in it, just give them a 0. And don't feel bad. You only need 60% to pass. And a graduate student also runs the class. So it's going to be okay. It's going to be all right. One is if someone has turned in something, but it is low effort and ignoring many, many directions. 2 is for decent effort, follow directions with some minor issues. And 3 is excellent. You read it and you're like, great. And that's all I have for you. Thank you all so much. Very excited for the quarter. Homework is due next Wednesday.